noise. Noise. Who make a noise? Karina, you make a noise. Karina, mute for you. When the index of the root, look, suppose it's square root. Square root, any expression. Equal 10. Or when there's 4 roots, and so on. So when the index of the root is even number, in this case default is 2 because it's a square root. So normally when it's a square you omit these 2 because everyone knows gets 2 square root. 4 root, 6 root, and so on, you need to check it. However, when you have radical equation that involve odd index, no, you don't need to check it because, good evening, okay, because, pay attention, Karina. Yeah, you are late. So when you raise to the cubic power, because I want to remove this radical, this is any, equal 1000. And this equation, yes, this equation is completely equivalent, complete 100% equivalent. Equivalent anytime, equivalent 100%, and you don't need to check it in the original list. Keep in mind, because I promise, we're using this idea after that. Okay? When there's a square root, it's the most common, you need to check it. When there's a cubic root, no. Because the reason is because cubic root of one expression is equal when you raise to the cubic power is equal x, always. In this case, no. In this case, no. The square root x squared. Not always is x. No. The majority of the case, yes, 99%. But exists 1% that you can see now today, in which you need to verification. Okay, let me see. We are recording. Yeah. Okay. So let's see example. No, blah 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 blah. No, not too much. Let's see example. You copy the idea? I suppose you copy everything in your notebook or no? Answer me, yes or no? Okay, yes, okay, super. Yes, okay, excellent. Me too, I am a student, I like to copy, because while I copy, I understand. Okay, let's take example. Let me start for elementary kindergarten example. Example 1 first, super easy. Okay, we have only one radical. Square root 2x minus 1 equal 1. Okay, super. This is easy, I know. But you apply the key idea, square. So I recommend that you don't touch. No. Don't touch. Don't touch the original equation. Because I don't want to contaminate this equation to any algebra in order to verification the potential solution into the original equation. Let's copy again. Now the key idea is a square. So you have 2x minus 1 without square root, because I know the square, power, and square root cancel out each other, and the answer is 1. So you get elementary linear equation in this case, no? And you solve for x. So 2x is equal 1 plus 1. And move this negative 1 to the right hand side, like a positive 1 is 2 divided by 2, divided by 2, divided by 2, x is equal 1. And this is my potential solution. I need to verification. To verification, I go to the original equation and substitution. So the checking part is extremely important for me. Checking for x equal 1. See, the answer is true, perfect. We get the answer. See, the answer is false. So in this case, we have only one possibility and we have no solution. But no, in this case, yes. And now you substitution. square root 2 times 1 minus 1. The thing I am doing is replace x equal 1 into the original equation. Here I claim this statement. I don't know if it's true or false. It's obvious it's true because 2 times 1 is 2, minus 1 is 1, and square root 1 is 1. 1 equals 1. This is super true. Therefore, this solution is perfect. Now, if you want, you copy like that. Solution set is 1. Only one value. Any question? Okay. Let me try one more example. Interesting, more interesting. Because this brings me a new idea. Bring me that we have only one radical, but bring me that some solution is wrong. So you need to check it mandatory, the solution. Okay. Okay, example 2. Guys, let me know if you copy. If you don't copy, you finish to copy or no? You finish to copy? Yes, no? Come on,
Yes.
Yes, okay.
Yes, yes.
Example 2. Using the chat, maybe. Activate the microphone temporarily. This is a square root x plus 8 plus 12 equal x. This is my equation gets given like that. My equation always is solve for x. I need to find x equals something, one value or two values, I don't know, to satisfy this equation. Okay. Now remember, don't touch never the original because I use it in the last moment. However, in the second line, I isolate the radical. This is extremely important. Isolate the radical. So then 12 is moving to the right-hand side, like that. And this is a moment to square. When the radical is totally isolated, this is a moment to square. And now you have x plus a without radical. That was the intention. And you multiplication, why not? This and this. And you FOIL. X times x squared. X times minus 12 is minus 12x. Minus 12 times x is minus 12 again. It's logical because they are twin brothers. And negative 12 and negative 12 together, multiplication is positive 144. Okay, and the next time I do some algebra, I combine like term, I see, wow, look at that. Negative 12 and negative 12 together is 24. We combine like term is minus 24. Minus 24 plus 144. So in this moment, I stop. I see, wow, what kind of equation it is? Okay, we studied last class. It is. What kind of equation it is? It's confusing, right? I am not sure. It's confusing. It's a quadratic equation, yes or no? It's a quadratic equation, yes or no? Of course, it's not already in a standard, nice, elegant to start. No, I know. But the clue que give me information, the quadratic is this guy. When you see in the equation at least one term that contains x squared is quadratic. Si do not contain x squared, entonces linear equation. But this is quadratic equation. What should I do? Well, okay, I try to express in standard. Remember, standard is ax squared plus bx plus c equals 0. And now, normally, one side, right-hand side or left-hand side, depending, it's up to you, is 0, and you move everything to the one side. In this case, we have 1, 2, 3, 1, 2, 3, and we have 1, 2. So I propose you bring the 2 to the right. Then, now you have the left-hand side 0. That is x squared bring down, minus 24 bring down, plus 144. Minus x, minus 8. So the thing I did was X and A, I move. And what we have in the left hand side? Nothing, and nothing is 0. Okay, now 0 is equal X squared. One more time, we combine line term. We have line term here, negative 24 and negative X. Okay, I suppose que this coefficient is negative 1. Entonces, negative 24 and negative 1 together is negative 25. X plus something. So we have here numerical. And numerical, we have like a light term again, and we combine is 136. Okay. However, I don't feel good. Almost is clear, but no. I interchange. I put it here, x squared minus 25x plus 136 equal to 0. Oh, nice. This is the quadratic equation. Exactly, we need to start the process. And you see, guys, the quadratic equation is important, and the efficiency way for solving the quadratic equation is the quadratic formula. That formula that we're using yesterday or last class, and we continue throughout the semester using this almost every day. Entonces I can see que A es 1, B es negative 25, and C is 136. A, B, C. I'm plugging in, minus B. And we found double negative. The negative of the formula and the negative of the negative 25. Okay, when you substitution here together, give me positive 25. Plus and minus the square root negative 25 squared minus 4 multiplication by 1 multiplication by 136. Everything divided by 2 times A, in our example is 1. Okay, and this is the moment that I use my calculator, of course. I focus in the expression inside the radical. That expression, we compute first of all. Order of operation, I need to respect the order of operation. As I put in my calculator, negative 25 squared, of course, positive 625. Subtraction. And multiplication 4 times 1 gets so big as 4 times 136 is 544. Okay, now subtraction. When you subtracting this guy is 81. And we compute the square root 81 que es 9. Okay, entonces now so far we have 25 plus or minus 9 divided by 2. Okay, that's the thing I need to compute. Remember my recommendation, you split into parts, using plus, and using negative, using minus. The 25 plus 9, 34. And 34 divided by 2 is 17. Yeah, I close in the box this because this is potential solution. And 25 minus 9 is 16. And 16 divided by 2 is 8. Okay, we have two potential solutions. I need to investigate. See this potential solution work or doesn't work in the original equation. Okay, so I split the page in two parts because I want to check it. Check it for 17 and after checking for 8. And finally here I write solution 7. Okay, let's do it. And the original equation. What is the original equation? This is the original equation. This is the original equation. Entonces, square root 17 plus 8 plus 12 outside should be 17. I have no idea if this statement is true or false. 17 and 8 together is 25. And the square root 25 is 5. And 5 plus 12 is 17. Absolutely perfect. 17 equals 17. Entonces, inside my solution set, we have 17. Comma, I have no idea if A work or doesn't work. Again, plugging it into the original. A plus A, so you replace x equal 8 here. Plus 12 should be 8. Question mark again. A plus A, 16. Square root 16 is 4. And 4 plus 12 is not 8, it's 16. 16 equal is a completely false statement. This was completely true statement. Therefore, the solution A doesn't work. Now, so we have only one solution, que es 17 in our radical equation. Any question? I know it's too long, but this is not the point. I know it's too long, and you need to be careful with the algebra. You apply the key idea, you square both sides. Manipulation. Entonces, finally, we're ending in quadratic equation. Okay, you solve the quadratic equation using quadratic formula. And end the story. Quadratic formula, important, super important. Any question, guys? Come on. Melanie, is okay? Emily Alonso, everything is clear? Come on, let me know. Now, of course, you need practice, huh? Okay, good. It's no big deal. It's no big deal, professor. Okay. Do you copy? I can erase the board? Sure? Don't? Erase? Erase or no? Erase. Okay, now example 3 is a little bit more complicated and long. The reason is because we have two radicals. It's a plus 1 equal 1. Entonces, the typical mistake make students is the student believe que one radical minus another radical, you can square both. No. This is impossible. You isolate one radical and square. Yes. And after manipulation, you isolate another radical and square. Yes. This is the way. We cannot eliminate both simultaneously. You know, I wish, you wish, but no, it's incorrect. It's impossible. Okay, so now I make a decision, isolate one radical. I don't touch the original, never touch the original. I make a decision to isolate the first radical. Therefore, you move the second radical to the right-hand side, like a 1 plus square root x plus 1. Okay, now square. This is a moment to square. At least you eliminate one radical. Another no. Another stay alive, but this no. 2x plus 3. At least I eliminate the first radical, but the second no. But the second I need to FOIL. It's similar. You FOIL this binomial times this binomial. And you FOIL 1 times 1 is 1. Okay, 1 times 1 is 1. 1 times a radical is just the radical because the 1 is invisible multiplier. Okay, likewise, this time this is exactly the same. And finally, the last, que es el radical times radical, you know, que radical any expression times radical any expression with this same expression or number is any without radical. Because actually it's square root any square. Any time any is any square. And the square power and the square doesn't matter, it's inside, outside cancel out each other. And you suppose que es just x plus 1 without radical. Do you follow me? This idea? Okay. Now, well, I need to combine later. I can see que this one and this one, there are no reason to copy separately. No. You copy 2x plus 3, and 1 plus 1 is 2. Doesn't matter if you put here or in the last part. And this radical, you adding two radical equal radical any plus radical any is equal twice radical any, no? That's different to the multiplication. This is addition. Entonces 2 times radical x plus x. Okay, entonces in this intermediate step, you do something. You apply the key idea and you eliminate one radical. However, stay alive another radical. What is my goal? My goal is isolate this second radical and apply one more time the key idea, que es square. Okay, let's do it. So now I propose you 2x, I copy, plus 3. I move 2 and x to the left, like a minus 2 and minus x, and stay only in the right hand side 2 times radical x plus 1. And one more time, we combine later. 2x minus x is 1x. And 3 minus 2 es obvio que es 1. No, black color. Plus 1. Black color. Plus 1. In the right hand side, we have 2 radical x plus 1. This is the crucial moment, and when you apply one more time the key idea, square both sides. Because my intention now is eliminate the second radical. This is step by step. Okay. So now, in the left hand side, we have the multiplication x plus 1 times x plus 1. And you apply one more time FOIL. Let's do it. You multiply x times x squared. You multiply x times 1, it's just x. 1 times x is just x again, and 1 times 1 is 1. Let me continue working in the left hand side because we need to combine later again. Entonces x squared plus 2x plus 1. And stop here. I finished the manipulation of the left hand side. Let's do it now right hand side. Well, right hand side is weird because suppose que you have, for example, 2a and you square. It's so because 2 squared times a squared. It's no FOIL. It's monomial expression, not binomial. So say 2 squared is 4 and a squared is a squared, no? In this case, 2 squared, okay, 4, and square root x plus 1 is squared. I know that this guy is 4. Yeah, I know that this is square power and square root cancel out. Again, we see that. But very, very important, the most important moment is you copy like that, x plus 1, but with parentheses. The reason is with parentheses is because the arithmetic operation in between 2 to the second power and this is invisible time here. So you write like that, look, 4x plus 1. I suppose that 4 multiply only x. That is wrong. Like this is very important. When you remove this parenthesis, you enclose everything in the parenthesis because this 4 multiply x and this 4 multiply 1. So my equation is 4x plus 4. And one more time, we have quadratic equation. Quadratic equation. Okay, we need to write in standard. Always, when you solve in the quadratic equation, the efficiency way to do that is express it in standard. So x squared plus 2x plus 1 minus 4x minus 4 equal to 0. And one more time, we combine lighter. Who is lighter? This and this are lighter. And this and this are lighter. So it's x squared minus 2x, because positive 2 and negative 4 together, a subtraction, you put the sign of the bigger number, get negative 4, and 1 minus 4 is negative 3, equal to 0. Uy, uy, uy. And this is my equation, my quadratic equation that I need to solve. In this case, you have two possibilities, no? Solving using the famous quadratic equation, it always is possible. The only disadvantage of this method is that it's too long. However, my recommendation is, depending on the problem, see it's easy or complicated, in this case, extremely easy, do by factorization. Because I need to find, so the variable is x, two numbers can multiply each other, give me 3, and somehow, when you adding all subtraction, give me 2, it's always get 3 and 1. Because 3 times 1 is 3, and 3 minus 1 is 2. And the corresponding sign, what sign? Well, I suppose that this is negative and this is positive. And make sense because negative 3 times positive 1 is negative 3, exactly like that. And negative 3 plus positive 1 is negative 2, exactly like that. When it's possible factorization, I highly recommend it. When it's, you see get something weird or you don't know, no problem. We are doing in that way. If you want, I solve in this way, but no, because we have too much work. Yeah, I see the easy way. And now you separate these two factors in two linear equations. The first one is x minus 3 equals 0, or x plus 1 equals 0. So basically, this is classical. When you have several factors, 1 factor, 2 factor, 3 factor, x equal to 0, it's because this factor is 0, this factor is 0, this factor is 0, or everything is 0. It's equivalent to right or. So x equal to 3 is my first solution. I move 3 to the right hand side, positive. And x equal negative 1 is my second solution, que is, I bring 1 positive to the right, like a minus 1. And so this is a moment, because it's too long, wow, too long process. Okay, I'm totally exhausting and tired. Wow, too much for me. I put this solution in the test, and then when I grade the test, I see that you don't checking, and the checking is the 50% of the total grade. 100 points, 50 points for solving that, and 50 points for checking. You say, bueno, pero checking is easy, professor. Well, it's easy, but it's important. And si you omit this, you have 50 points. Okay, so now you're using always the original equation. Always the original equation. I copy to time, because we have two potential solutions to checking. And use substitution for 3. For 3. Okay, let me try. Square root 2 times 3 plus 3 minus square root 3 plus 1 should be 1. I have no idea. Since the statement is true or false. 2 times 3 is 6. 6 plus 3 is 9. 3 plus 1 is 4. Square root 9 is 3. Square root 4 is 2. And 3 minus 2, of course, is 1. This is completely true. That means that the solution is perfect. I have no idea about the second solution. Again, it's the same procedure, but substitution negative 1 into the original equation. It's doing square root 2 times negative 1 plus 3, everything inside the radical, minus square root negative 1 plus 1 should be 1. I have no idea. Here I have no idea. Oh no, here, sorry. So now let's do in the operation inside. The operation inside is negative 1 times 2 is negative 2. And negative 2 plus 3 is 1. Okay, nice. And operation here is negative 1 plus 1 is 0. Square root negative 1 is 1, square root 0 is 0. Yes, obviously, yes, it's true, because 0 is nothing, 1 minus 0 is equal 1. Both solutions are true. So not always, so there are no rules. There are no specific rules, depending on the problem. Sometimes happen you have the solution of both are true. Sometimes have the solution and one is true and another not true. And sometimes very, very weird, but happen, okay, both solutions are completely false and we have no solution in this radical equation. Any question? Any question? Oh, again, the forest. The rainbow, the forest. The forest, I don't like this forest. I am working in my office, not in this forest. You, let me see if I can. No, I suppose que no. A second. Here, choose effect background. No effect background. Okay, and that's it. No? How you close that? No, I have no how remove it. Okay. Okay. Entonces, no question. Everything is happy. Let's move on to the one more example. One more example. Okay, a little bit weird. This is example 4, no? A4. 1, 2, 3, 4. Yeah. Example 4. In example 4, we have, let me see, in my paper, square root 3 minus 2 radical x. Wow, it's one radical inside another radical. Is equal square root x. Okay, as always, I copy again my equation because I reserved my original equation to the last moment. And you apply the key idea, square both sides. Okay, so this big radical is cancelled out with this 2. We have 3 minus 2 radical x. And this, unfortunately, is also x. Okay, good, super good. So we remove 2 radical in this case because this radical is located in different side. As it was possible to remove simultaneously, but not always, no? What should I do now? I have no idea. Well, isolate the last radical. Isolate the last radical. So we have minus 2 radical x is equal x minus 3. Because I move 3 to the other side, and you square both sides. Entonces, negative square become positive, you know. And 2 square is 4. And the square of the square root is just x. In this case, no. In this case, you FOIL, because it's binomial. It's x minus 3 times itself. X times x squared. X times minus 3 is minus 3x. Minus 3 times x is minus 3x. And minus 3 times minus 3 is positive 9. One more time, I can see light terms. We combine. Okay. Now, 4x is equal x squared minus 6x plus 9. Okay, it's ready the quadratic equation. Again, it's quadratic equation. Look at that. Look, quadratic equation. This is the, when you see at least one term that contains square power, second degree, degree 2, it's because it's quadratic equation. Si es una equation like that, 2x plus 3 equals 5. No, this is a linear equation. Not necessarily quadratic formula. No. In this case, yes. But you need to organize in standard. So I propose you, this guy stay here. And this 4, I move to the other side, like a minus 4x. And this is 0. It doesn't matter the order. The order is not important. However, I saw, okay, this and these are lighter. We combine. This is 0 is equal x squared minus 10x plus 9. To feel more comfortable, I interchange the equation. I put the equation in the left-hand side. And the right-hand side is 0. Nice. This is a standard, super standard form to express in the quadratic equation like that. Ax squared plus bx plus c. Es obvio que a es 1. Es obvio que b es minus 10. Es obvio que c es 9. Entonces, this I make a decision. I solving by quadratic formula or no, or by factorization. Entonces you spend only 2 seconds, not 3 seconds, only 2. So you don't see the possibility of the combination of the factorization. Entonces immediately you switching to the quadratic formula, no? Okay, always we get the answer, no? I know that the only disadvantage is a little bit long, but in this case, let me see. Okay, yeah, I can see the combination is 9 and 1, because 9 times 1, so 2 number, a multiplication, give me C, it doesn't matter the sign for a moment, and addition, give me B. In this case, obviously is negative, both, because negative 9 times negative 1 is positive 9, exactly C. And negative 9 plus negative 1 together is negative 10, exactly like that. Negative 10. Okay, so this is a combination. In my opinion, this is the easy way. And another example that you don't see the combination, don't worry, don't be scared. You go here and we get exactly the same answer. So why proof? Okay, now to say in this moment, I separate into binomial. The first one is 9, the second one is 1. And you solve. There's one potential solution is 9. Another potential solution is 1. Yeah, you are doing 50% of the problem. The another 50% is the checking part. Que es easier, but it's important. The checking part. Okay, where? And the original. This is the original. I copy here because I want to see near me. Okay, now substitution for 9. X equals 9. Square root 3 minus 2 times square root 9 should be square root 9. Wow, what the hell is that? Look at that. Square root 9 is 3. 3 times 2 times 3. Square root 9 is 3. And square and 2 times 3 is 6. 3 minus 6. And square root 9 is 3. So on the right hand side we have 3. Well, on the left we have something weird because 3 minus 6 is negative 3. And you know que square root negative number is imaginary, so never is equal to 3. Therefore, the solution is wrong. Let me try with the 1. X equal 1 into original. Square root 3 minus 2 times radical 1 should be equal radical 1. Okay, this is 3 minus radical 1 is 1, and 1 times 2 is 2. And radical 1 is 1, and 3 minus 2 is 1. And radical 1 is 1, 1 equal 1. This is completely true. That was completely false. That is a reason que I discard the solution, but no, 1 is a super good solution. Okay, entonces the solution, the conclusion is que the solution set of this equation is just one number que es 1. End the story. Any question? Any question? You feel strong? And
Hello?
Do you feel strong?
Can you repeat the multiplication within the radical first one? 9.
Yeah, of course, absolutely. Look, the multiplication in the radical was Mr. Square root 9 was 3. 3 and 2 together, multiplication is 6. And 3 minus 6 is negative 3. And negative 3, what the hell is that? It's I radical 3. Because I know that the negative quantity inside the square root is imaginary and should be equal positive 3 is real, no? Okay, got it? Mister, answer me.
I got it.
Eso, bueno.
Thank you.
No problema. Entonces, how do you feel? Well, you feel maybe concerned a little bit because it's too long, no? But okay, guys, you are taking college algebra. This is not gonna get the intermediate algebra or something. No. I teach in the morning intermediate algebra, but in the evening, afternoon, I teach in college algebra with you, no? So no, don't expect easy problem. Don't expect short problem. No short. Okay, let's do another topic. Remember, in this chapter, que es the first chapter, we study complex number. We study the equation que we use in the chapter 2, I promise. So we need to be strong for solving any equation. So now let's discuss it now polynomial equation. And one specific kind of polynomial equation that's important is quadratic form. Quadratic form. Don't worry for the name, because in your moment I explained it, what the reason is the name. And the clue to identification, the kind of equation. The radical equation was easy identification, no? Because when you have radical, it's a radical equation, no? It's obvious. But what about polynomial? This name, polynomial. Well, the idea is clear. It's a polynomial when the exponent are whole numbers. Whole number. What is whole numbers? When a whole number is 0, 1, 2, 3, and so on. No negative, no fraction. Okay, this is when you have, for example, that equation. Let's do example number 1 of the polynomial. No? This x cubed minus x squared minus 2x equal to 0. By the way, this equation is expressed in standard because right-hand side is 0 and is organized in descending order of the degree. 3, 2, 1, and not 0. In this case, no. Now, the efficiency way for solving, they are no formula. No, well, they are formula, but the formula is crazy. Okay, it's important to understand that the degree of this polynomial 3, okay, the higher exponent. Therefore, when you finish that, we expect 3 solutions. Include real solution and complex solution. Okay, or imaginary, or pure imaginary, pure real, or complex, es a combination both. Okay, entonces now, identification polynomial. When the exponent are always, si the exponent is supposed negative 3 here, boom, no polynomial. If the exponent here is 1/3, boom, no polynomial. Okay, not necessarily the leading, sino si it's supposed to 1/2 here, no polynomial. It's another kind of equation que have another name, and the name is not important. Okay, so polynomial. So now I need to recall, because we solve it always in the same way, using factorization. The factorization, you need to remember GCF, related common factor. You need to remember factorization trinomial. You need to remember factorization by grouping. I want to record everything now and then several examples. And why not a difference of square. Let me copy the formula that you suppose you remember very well. A squared minus b squared, the factorization is a plus b, a minus b. Okay, the factorization, when you see the binomial like that, you separate in 2, and this difference of a square, And difference of cubic also is a little bit more complicated, but it's okay. It's a formula. A cubic minus B cubic is A minus B, parenthesis A squared plus AB plus B squared. These are formulas. So GCF, this is the collection of the most important factorization that we need to use. Trinomial, the trinomial is super easy. You open two parentheses. Let's do it by grouping. There's 4 terms. And difference of square, binomial, like that. Difference of square, not necessarily the exponent is 2. Maybe it's 4 or it's 6. But it's even, it's difference of square. Consider it like it's different. And difference of cubic, no necessarily it's 3. Maybe 3, maybe 6. Or no, 6 is 2. Maybe 9. So any multiple of 3 is considered like a cubic. 6 is considered like a both, no? Because that is a coincidence that 6 is multiple of 3 and it's also even, no? But okay, don't worry. I explain the factorization one by one detail now. For example, in this example number 1, I start. Is there common factor or no? In my expressions, in my monomial, in my term one by one, is there a common factor? I can say yes, professor, the factor is x, because x is here, and here. Therefore, the greater common factor is x. But how many x? 1, 2, or 3? Only 1, because x cubic in my mind is like x times x times x, multiplication 3x. X squared is x times x, and x alone to the 1 power is just x is x. Therefore, I can see that the common factor is x, and the rest is not common. Okay, a factor out 1x. Open parenthesis and copy inside the remaining part. See, you have